Section 10.6 is on translating conic sections. In this section, we're going to take a look at how do you move an ellipse or a hyperbola from being centered at the origin to being centered somewhere else. We've actually already done this with parabolas and circles, but now we're going to focus on the ellipses and hyperbolas. So several text boxes from your textbook, which I would not go through the bother of memorizing all of this. I think we can actually figure a lot of this out as we go along. So the main idea is, instead of having something like this one here, x squared over a squared plus y squared over b squared equals 1, now we're going to add our h and k, because that's going to be our new center, as we've seen with all sorts of functions that we've looked at this year. So a horizontal ellipse centered at hk is going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. The vertices, covertices, foci will also translate, and we're not going to memorize those, we're just going to figure it out. And this is important, this ABC relationship stays the same, c squared equals a squared minus b squared. Okay. Now, for a vertical ellipse, remember in this case, since a is always going to be greater than b, a squared was under y squared, and that means it's going to open more along the y-axis. We're going to have the same thing here, so x minus h squared, this time over b squared, plus y minus k squared over a squared equals 1, and then that same relationship exists. It's going to be very similar for horizontal and vertical hyperbolas. Again, we're going to have our new center at hk. Remember, a hyperbola has a minus in there. A is not necessarily bigger than b, but whichever one comes first determines the direction it's going to open. So for a horizontal hyperbola that's going to open on the horizontal axis or the x-axis, x comes first, so x minus h squared over a squared minus y minus k squared over b squared equals 1. And then remember, the relationship between a, b, and c in a hyperbola is basically the Pythagorean theorem. For a vertical hyperbola, the center at hk, notice that y comes first, and remember a does not have to be bigger than b, and the relationship again is the Pythagorean theorem. I'm actually not going to refer to those charts. I'm just going to figure it out as I go along here. So let's take a look at this example. Write the equation in standard form of an ellipse that has with vertices at -6, -2, and 12, -2, and one focus at the x-coordinate of 3 plus 4 square root of 2 and the y-coordinate of -2. Then we need to graph the ellipse. I'm going to start by graphing those points. So I have one vertex at -6, -2. I'll label that with a V. My other vertex is at 12, -2, oops, which is actually going to be off of here, but it's going to be right about here. There's my other vertex, and I'll worry about my focus in a minute. So actually that tells me a whole lot of information. Those are my vertices, so my major axis is going to be horizontal. So I know that this is going to be a horizontal ellipse. And my basic formula is going to be x minus h squared over a squared plus y minus k squared over b squared is equal to 1. So what I need to do is I need to find the values of h, k, a, and b. Let's start with h and k. My center is going to be the midpoint of the major axis. So the major axis is this line between the two vertices. That center point is going to be right here at 3, -2, because this is 9 units to here, from -6 to 3, and from 3 to 12 is also another 9 units. So that's actually going to be my center. So my center is at 3, -2. That tells me that h is 3 and k is -2. Now, this distance from the center to one vertex is what a is going to be equal to. Center to vertex is 9 units. I'll go ahead and write that here. Center to vertex is 9. Therefore, a is going to be equal to 9. What I don't know is what b is going to be equal to, and that's one that I'm going to have to figure out here. Now, I do have a focus that is on my major axis. And the coordinates of that focus are 3 plus 4 square root of 2, comma -2. And that -2, notice that's been the same for my vertices, for my center. That makes sense because they're all basically on that line y equals -2. This value right here, I plugged it into my calculator, and that's approximately equal to 8.7. So I'm going to have a focus out here at 8.7, which is going to be about 8.5. I'll have one focus there, and then I'll have my other focus 8.5. Oh, that's one. Oh, okay, so then that distance there is going to be my C. So from my center to my focus, that distance is C. And since my x-coordinate here is 3, and I added 4 square root of 2, that means, that my C is going to be equal to 4 square root of 2. So now I can use the relationship for an ellipse, c squared equals a squared minus b squared, to figure out what my b is going to be. So I will have 4 square root of 2 squared is equal to a squared minus b squared. 4 square root of 2 squared is 4 squared, which is 16, times square root of 2 squared, which is 2. 16 times 2 is 32, is equal to 81 minus b squared. So b squared is equal to 49. So my b is equal to 7. And actually I can use that to help me graph. So that's the distance from the center to the co-vertex. So if I want to go up 7, and 2, 4, 6, 7. Those are going to give me my co-vertices. I could go ahead and graph this now. Okay, that's not the best looking ellipse, but that's okay. And now I have enough information to write my equation. So I'm going to have x minus h, which was 3, squared, over a squared. A was 9, so over 81, plus y minus k, so y minus a negative 2 is y plus 2 squared, over b squared, b was 7, over 49, equals 1. And let's see, did I get everything there? I wrote the equation, I graphed it, and you'll notice I didn't go back and refer to the first page of these notes to figure out what the formulas were. I just used what I knew about where the vertices were, what the major axis is, how I figure A, B, and C, and plug those into the formula. And our last example here deals with a hyperbola. Oops. So this one says, for the hyperbola, y squared over 36 minus the quantity x minus 4 squared over 16 equals 1. We need to identify the center, the vertices, the foci, and the asymptotes, and then graph it. Okay. Looking at this equation, I notice that y comes first. And I know that in a hyperbola, if y comes first, then it is vertical. In other words, this is going to be opening up and down. It's going to look like this and this. Okay. Looking at my equation here, k is going to be equal to 0 because k is what's being subtracted from y. H is what's being subtracted from x, so h is 4. So that tells me that my center is going to be the point 4, 0. And that's one thing I needed to find. Let's go ahead and graph that. My center is 4, 0. And I'll label that so I remember what it is. Now, a always comes first. So if a squared is 36, then a is equal to 6. B squared is equal to 16. So b is 4. And those are going to tell me where my vertices are. So to get my vertex, a is going to be, in this case, vertical, going up and down from the center. So I need to go up 6 units. So there's one vertex. And then I need to go down 6 units. Is that 6? Yeah, there's my other vertex. My co-vertices are going to be 4 in either direction. Okay. And that's going to help me. Maybe I will go ahead and do the graph now, as long as I've got these points. Remember, the vertices and the co-vertices define a rectangle, which I will do dashed here. You could also do this in a different color. Kind of makes drawing it a little more fun. Okay. The diagonals of this rectangle are my asymptotes, so I will draw those. Okay, and then my hyperbola goes from the vertices, and it is asymptotic. Oops, I need to pull this down a little bit more to draw. Maybe I should have extended my asymptotes a little bit there. Okay, so there's my graph. Now from this graph, let's go ahead, as long as I'm looking at the graph here, I can figure out my asymptotes, not using one of those formulas, but just by looking at what I have here. So let's start with this line that has a positive slope. So I went up 6 and right 4. So that means, let's see, let me identify these here. Okay, I'm going to have the line y equals, my slope of up 6 and right 4 is a positive 3 over 2. X, and this one's actually kind of nice. I can tell that it crosses the y-axis at -6, so my y-intercept is -6. For the line that has a negative slope, I basically go up 6 and left 4, so that's going to give me a slope of -3 over 2x, and in this case my y-intercept happens to be a positive 6. So there are my asymptotes. What else did I need to find? I needed to find the vertices. Okay, I've got those. So my vertices are the points 4, 6 and 4, -6. And I need to find my foci. I have not done that yet. So in order to find the foci, I'm going to say I need to find c. So c squared is equal to a squared plus b squared. So c squared is, let's see, a squared was 36, b squared is 16. So c is going to be equal to the square root of 52, which simplifies to 2 square root of 13, which is approximately 7.2. And I'm going to use that to graph, because remember the foci, the foci are going to be inside the bowl, and they are going to be approximately 7.2 units from the center. So that was 6, 7.2, so I'm going to have a focus there. And that was 6, 7, and a little bit more. I'm going to have a focus approximately there. So the coordinates of those are going to be 4 and, oh yeah, and basically I went up 2 square root of 13 and down 2 square root of 13. So my foci are at 4, 2 square root of 13, and 4, -2 square root of 13. And I think I answered all of the parts there. So in this section, we took a look at translating not all of our conic sections, since we already did circles and parabolas, but how to translate ellipses and hyperbolas. And there's a lot of information, a lot of letters, a lot of stuff that you could memorize, but I think if you just memorize a few things and you draw the graph, you can figure a lot of it out from the graph.